In the summer of 1944, the German army in Normandy was fighting a defensive war masterclass. Their Tiger and Panther tanks were superior to the American M4 Shermans in almost every metric: armor, gun range, and firepower. In engagement after engagement, the Germans would inflict horrific losses on U.S. armored columns. A German Tiger company might ambush an American battalion, knocking out 15 or 20 Shermans in a single afternoon. The German commanders would survey the battlefield through their binoculars. They would see the columns of black smoke rising from the American wrecks. They would radio back to headquarters: enemy armored force destroyed. Sector secure. On paper, it was a victory. The Germans calculated enemy strength based on attrition. They knew how long it took to build a tank. They knew how long it took to ship a tank from Detroit to France. They assumed that a knocked-out tank was a dead tank. In the German army, when a tank was hit and the crew bailed out, the vehicle was usually written off. Recovery was difficult. Repair required sending the tank back to a depot in Germany or a major rail hub in Paris. So, when they saw a Sherman with a hole in its side, smoke pouring out the hatch, and the tracks blown off, they counted it as a permanent loss for the Americans. They believed they were bleeding the U.S. Army dry. They believed that if they destroyed 50 tanks a day, and the Americans could only ship 40 a day, the American offensive would eventually grind to a halt. This was the paper victory. It was a dangerous delusion based on the German way of war. They didn't understand that the U.S. Army had a completely different philosophy regarding damaged equipment. They didn't know that behind the combat units, there was a second army. An army not of soldiers with rifles, but of mechanics with wrenches. As soon as the sun went down, or even while the battle was still raging, this second army would move in. They would look at the smoking wrecks not as garbage, but as puzzles to be solved. And more often than not, the tank that the Germans had counted as destroyed on Tuesday would be back on the front line, shooting at them, on Thursday. To understand why the Germans underestimated American repair capabilities, you have to look at their own logistical nightmare. German engineering is famous for its precision and performance. But in World War II, that precision was a liability. Take the Tiger tank or the Panther tank. They were magnificent fighting machines, but they were maintenance disasters. The Tiger used a system of interleaved road wheels. The wheels overlapped each other to distribute the massive weight of the tank. It provided a smooth ride and a stable gun platform. But if an inner wheel broke, or a bearing seized, the mechanics had to remove 4 or 5 other wheels just to get to the broken one. In the mud of Russia or France, this could take an entire day. Changing a transmission on a Panther tank required a heavy crane to lift the entire turret off the hull. This meant the tank had to be towed to a rear-area workshop equipped with a gantry. You couldn't do it in a muddy field under mortar fire. Furthermore, German parts were not always interchangeable. A part from a Tiger built in 1942 might not fit a Tiger built in 1943 without hand-fitting and machining. This lack of standardization meant that German recovery units were constantly overwhelmed. When a German tank broke down or was damaged, the crew often had no choice but to blow it up, scuttle it, to prevent capture. Hundreds of Tigers and Panthers were destroyed by their own crew simply because they had a broken final drive or a seized engine and no way to fix it. The German commanders assumed the Americans faced the same problems. They assumed that a hit to the engine block or a shattered transmission meant the tank was scrap metal. They projected their own logistical fragility onto the enemy. They didn't realize that the M for Sherman was designed by a nation that worshipped mass production and ease of maintenance. The Sherman was not a Swiss watch. It was a tractor. It was designed to be fixed by an 18-year-old farm boy with a wrench and a hammer. While the German mechanics were cursing their over-engineered suspension systems, the American mechanics were performing miracles of improvisation that would have horrified a German engineer, but kept the tanks rolling. The hero of the American armored force was a vehicle most people have never heard of. The M32 Tank Recovery Vehicle. It was an ugly, turret-less Sherman tank fitted with a massive A-frame crane, a winch with 60,000 pounds of pull, and a mortar for laying smoke screens. It was the tow truck from hell. Every American tank battalion had a maintenance platoon equipped with these beasts. Their job was arguably the most dangerous on the battlefield. When a Sherman was hit, the M32 crews didn't wait for the battle to end. They moved in while the tracers were still flying. They would fire smoke mortars to hide their position. Then, the crew would jump out, hook heavy steel cables to the disabled tank, and winch it out of the line of fire. The M32 could drag a dead tank through mud, up hills, and out of ditches. The German equivalent, the Berge Panther, was rare and valuable. The Germans hesitated to risk them. The Americans used the M32 aggressively. Once the damaged tank was dragged to a collection point just a mile or two behind the lines, the triage began. The ordnance officers were like battlefield surgeons. They classified the damage. Class A, fixable within 24 hours by the unit mechanics. Class B, requires a heavy shop, sent to the rear. Class C, total loss, burned out or melted. The Germans assumed most hits were Class C. The Americans proved that almost anything was Class A if you had enough spare parts and enough coffee. The M32 crews developed a cult of toughness. They prided themselves on stealing tanks back from under the noses of the Germans. They would crawl under tanks to attach cables while machine gun fire sparked off the hull. Because of the M32, the battlefield was not a graveyard for American tanks, it was a temporary parking lot. The Germans would knock a tank out, and an hour later, the M32 would drag it away like a zombie being dragged back to the grave, only to rise again. The ultimate proof of the difference in philosophies was the engine swap. In a tank, the engine is the heart. If it takes a shell fragment, or if it blows a gasket from being pushed too hard, the tank is a 30-ton paperweight. For a German Panther crew, a blown engine was a catastrophe. As mentioned, it required a heavy crane, a specialized workshop, and days of labor. It usually meant the tank was sent back to Germany by rail. For an American Sherman crew, a blown engine was a bad afternoon. The Sherman was designed with a rear engine deck that unbolted easily. The M32 recovery vehicle, or even a standard truck with a heavy A-frame, could lift the engine block straight out of the back of the tank. The connections were standardized. Fuel lines, electrical cables, and drive shafts utilized quick disconnect fittings where possible. A well-trained American ordnance crew could swap a Sherman engine in 4 hours. 4 hours. This meant that a tank could blow its engine at noon, be towed to the rear, get a new engine, often a crate engine straight from Detroit, and be back in the line for the evening attack. The supply chain supported this speed. American logistics pushed spare engines, whole engines, not just parts, right up to the front lines. They treated engines like ammunition. They were consumable items. Don't fix the piston rings, the order went. Just replace the whole engine and fix the old one later. This plug-and-play modularity was decades ahead of its time. It allowed the U.S. Army to maintain an operational readiness rate that defied logic. During the race across France, Patton's Third Army drove their tanks until the engines literally fell apart. The Germans expected Patton to stop to refit. Instead, Patton's mechanics swapped the engines on the side of the road at night, and the army kept moving at dawn. The German intelligence officers couldn't understand how the American formations maintained their strength. They were counting the kills. They knew they had shot the tanks. They didn't understand that in the U.S. Army, a tank wasn't dead until it was melted into a puddle. Until then, it was just in the shop. When an American tank was hit, it wasn't just a tragedy, it was an opportunity. In the rear areas of the American sector, in muddy fields that became known as boneyards, the Ordnance Corps perfected the art of cannibalization. This was the ultimate recycling program. A tank that was truly destroyed, a Class C burnout where the fuel and ammunition had exploded, tempering the steel and warping the hull, was useless as a fighting vehicle. But it was a goldmine of parts. The mechanics would swarm over the carcass like ants. They would unbolt the road wheels. They would strip the machine guns. They would pull the radios. They would take the seats, the periscopes, and even the wiring harnesses. Nothing was wasted. Why wait for a replacement part from Detroit when you could pull one off a wreck right there in the field? This led to the creation of Frankenstein tanks. You might see a Sherman at the front that had the hull of a 1942 model, the turret of a 1943 model, a new engine, and road wheels taken from 3 different knocked-out tanks. The paint wouldn't match. The serial numbers didn't match. But the gun fired, and the engine ran. The Germans found this deeply unprofessional. In the Wehrmacht, a tank had a pedigree. You didn't just slap parts from a Panzer III onto a Panzer IV. The lack of German part standardization made cannibalization difficult, even if they wanted to do it. A hatch from one Tiger might not fit another Tiger perfectly. But the American dedication to standardization meant that almost everything fit. This boneyard strategy created a closed-loop supply system right behind the front lines. It meant that a unit that lost 10 tanks in a battle might only get 5 brand-new replacements, but they could build another 3 working tanks from the wreckage of the 10 they lost. The Germans were fighting a war of attrition against an enemy who was constantly regenerating itself from its own dead. A tank is defined by its armor. When that armor is pierced by a shell, the tank is compromised. For the German army, a tank with a hole in its armor was a serious problem. Repairing hardened armor plate required specialized techniques, controlled heat treating, and X-ray inspections to ensure the integrity of the weld. Doing it wrong could make the armor brittle and shatter under impact. It was factory work. The American mechanics at the front didn't have factories. They had arc welders powered by generators in the back of a truck. They operated under a simple philosophy: patch it and send it back. If a shell punched a hole in the side of a Sherman but didn't set it on fire, the mechanics wouldn't send it to Paris. They would cut a square piece of steel plate from a wrecked tank in the boneyard. They would grind the edges of the shell hole smooth. Then, right there in the muddy field, Often at night under the glare of a floodlight, they would weld the patch over the hole. They called it battle damage repair. It wasn't pretty. The welds were often rough. You could see the scars on the tank's hull. But it stopped machine gun bullets and shrapnel. More importantly, it got the tank back into the fight immediately. The psychological impact on the crews was significant. They were driving tanks with visible patches over holes where previous crews had likely died. It was a grim reminder. But it also gave them confidence in the logistical system. They knew that even if they were hit, the tank wasn't necessarily done for. And it demoralized the Germans. A German anti-tank gunner might score a hit on a Sherman on Monday. He would see the crew bail out. He would mark it as a kill. On Wednesday, he might see the exact same tank, with a fresh, shiny weld patch on its side, advancing on his position again. It was like fighting an army of ghosts. The American willingness to accept imperfect repairs in exchange for speed was a crucial advantage. They realized that a tank with a patch is infinitely more useful than a tank sitting on a train car headed to a depot 500 miles away. The engine of the American repair miracle was not a tank, but a truck. The 2.5-ton deuce-and-a-half GMC truck was modified into a variety of specialized mobile workshops. The most important was the M16 machine shop truck. From the outside, it looked like a standard canvas-covered truck. Inside, it was a miniature factory. It was packed with a generator, a metal lathe, a drill press, a grinder, welding equipment, and a complete set of hand tools. These trucks were assigned to the ordnance maintenance companies right behind the front lines. They allowed the mechanics to manufacture parts that didn't exist. If a specific bracket snapped on a tank, and there were none in the supply depot, the machinist in the M16 truck didn't shrug his shoulders. He took a block of raw steel, put it on the lathe, and made a new bracket. It might take him all night, but by morning, the part was ready. They could rethread bolts, fabricate fuel lines, and repair complex gun mechanisms. This capability was unheard of in the German army at the divisional level. If a German unit needed a complex part machined, they had to send a request back to a factory in Germany. The American system decentralized industrial power. It put the factory on wheels and drove it to the sound of the guns. The mechanics who manned these trucks were highly skilled artisans, former tool and die makers, machinists, and factory foremen in civilian life. They worked under appalling conditions. Freezing cold, ankle-deep mud, artillery fire incoming. But the lights in the back of the machine shop trucks burned all night. These mobile shops ensured that the American army was never held hostage by its supply chain. If they couldn't order it, they built it. It was American ingenuity mechanized and mobilized. By late 1944, the German intelligence apparatus was in a state of confusion. The reports coming from the front lines didn't match the strategic reality. A Panzer Division commander would report, "We have decisively engaged the American 4th Armored Division. We claim 45 Sherman tanks destroyed. Their combat effectiveness is judged to be reduced by 60%. Based on this report, the German High Command would plan a counterattack for the next day, assuming they were facing a shattered enemy. But the next morning, the American 4th Armored Division would attack them with 80% of its full strength. The German commanders were baffled. Where are they getting the tanks? They would demand. They suspected the Americans had a secret supply route. They suspected their own troops were exaggerating their kills. The truth was simpler and more devastating. Of those 45 destroyed tanks, perhaps 15 were burned out, Class C. 10 were Class B damage, towed to the rear. But 20 were Class A, broken tracks, engine hits, jammed turrets. During the night, the M32 recovery vehicles had dragged them back. The mobile machine shops had fabricated the parts. The mechanics had swapped the engines and welded the holes. By dawn, those 20 tanks were recrewed, refueled, and rearmed, ready to attack. The German intelligence cycle, the time it took to gather reports, analyze them, and make a plan, was slower than the American repair cycle. The Germans were planning battles against the army of yesterday, while the Americans were fighting with the army of today, rebuilt overnight. This phantom strength allowed American commanders like Patton to be relentlessly aggressive. Patton knew that he could push his divisions to the breaking point, take heavy losses, and still have a fighting force the next day. He trusted his Ordnance Corps to perform miracles. The German High Command, stuck in their rigid calculations of attrition, never understood that they weren't just fighting the tanks on the field. They were fighting a logistical system that refused to let a tank die. The confusion at German headquarters was the direct result of the grease-stained hands of the American mechanic. If the American repair system was a miracle of resilience, the German system was a tragedy of fragility. And nothing symbolized this tragedy better than the Panther tank's Achilles heel. The Panzer V Panther was arguably the best tank of the war. It had thick sloped armor and a high-velocity gun that could kill anything the Allies had. But it had a fatal flaw deep inside its belly, the final drive. This was the set of gears that transferred power from the transmission to the tracks. The Panther was originally designed to weigh 30 tons. But as Hitler demanded more armor and bigger guns, the weight ballooned to 45 tons. However, the German engineers didn't redesign the final drive to handle the extra weight. They used the original, lighter gears. The result was a mechanical time bomb. The high-strength steel needed for the gears required rare alloys, specifically manganese, which Germany was running out of due to the Allied blockade. So, they used inferior steel. When a Panther driver tried to turn sharply in mud or accelerate aggressively up a hill, the stress on the gears was immense. Crack! The teeth of the final drive gear would shear off. The tank would grind to a halt, one track dead. This wasn't a simple fix. The final drive was buried deep inside the hull. To replace it, the crew had to remove the tracks, the drive sprocket, and several layers of armor plate. It was a job that required a workshop and days of labor. In the retreat across France, hundreds of Panthers were abandoned not because they were shot, but because their gears had stripped. German crews would weep as they set explosive charges in their own brand-new tanks. They had a weapon that could dominate the battlefield, but they couldn't drive it more than 150 kilometers without risking a catastrophic breakdown. The Americans knew about this weakness. They knew that if they could force the Germans to maneuver constantly, to turn, to reverse, to climb hills, the German tanks would destroy themselves. So the American strategy became one of constant movement. While the Sherman's engine and transmission were robust and easily swapped, the Panther was a thoroughbred racehorse with a broken leg. The German engineers had pursued perfection in firepower but ignored the reality of reliability. They built a tank that could win a duel, but couldn't survive a campaign. And as the roads of France filled with abandoned Panthers, the American mechanics drove past them in their trusty M32s, towing their own battered Shermans back to the fight, laughing at that superior German engineering rusting in the ditch. General George Patton was a cavalryman. He believed in the relentless pursuit. He hated the idea of sending anything to the rear. If you send a tank back to the depot, he argued, it's gone for weeks. I need it now. So, he issued a revolutionary order, fix it forward. He demanded that the ordnance maintenance companies move directly behind the combat battalions. He integrated the mechanics into the combat team. This was dangerous. Mechanics were working within range of German artillery. They were often strafed by the Luftwaffe. But it cut the repair loop from days to hours. Patton authorized ordnance contact parties. These were small teams of mechanics in jeeps or half-tracks who traveled with the armored columns. When a tank broke down, the column didn't stop. The contact party would pull over, fix the tank on the side of the road, and then race to catch up. If they couldn't fix it, they would tow it along until they could. Patton's philosophy was that a broken tank was just a temporary inconvenience, not a reason to stop the attack. He visited the maintenance battalions personally. He told the greasy, exhausted mechanics, "You are the ones winning this war. Without you, my army is just a collection of steel statues." He gave them priority on the roads. Normally, logistics trucks had to yield to combat troops. In Patton's Third Army, a tank transporter carrying a repaired Sherman had the right of way. This fix-it-forward doctrine created a sense of momentum that terrified the Germans. German intelligence would report that Patton's spearheads were overextended and must stop for maintenance. But the maintenance was happening while the spearheads were moving. The Americans were changing tracks during refueling stops. They were welding armor while the crews ate dinner. The line between combat and repair blurred. The mechanics carried rifles. They fought off German ambushes to protect their tool trucks. They were a new breed of soldier, the combat mechanic. And their weapon was the ability to deny the enemy the satisfaction of a kill. December 1944. The Ardennes. The temperature dropped to 0. The ground froze solid. In the Battle of the Bulge, the American repair crews faced their greatest challenge, nature. Metal behaves strangely in extreme cold. It becomes brittle. When a tank took a hit, the armor didn't just dent, it cracked. Welding became a nightmare. If you tried to weld a patch onto a frozen steel hull, the thermal shock would cause the armor to shatter. The mechanics had to improvise. They used blowtorches to preheat the steel for hours before striking an arc. They built tent structures around the tanks to trap heat. They worked with bare hands on frozen metal because they couldn't handle the small nuts and bolts with thick gloves. Skin stuck to steel. Frostbite was rampant. But the work didn't stop. At Bastogne, the surrounded 101st Airborne and elements of the 10th Armored Division were cut off from supply. Every tank was precious. The mechanics inside the perimeter performed miracles. They scavenged parts from destroyed vehicles in no man's land at night. They crawled out under machine gun fire to strip an alternator from a dead jeep to fix a command tank. They kept the few Shermans running on hope and ingenuity. Meanwhile, outside the pocket, Patton was turning the Third Army north to break the siege. This required moving thousands of vehicles over icy roads. Tanks slid into ditches. Trucks broke axles. The ordnance crews worked 24 hours a day. They pulled the tanks out of the ditches. They welded the axles. They kept the army moving when the weather tried to stop it. German commanders, whose own tanks were freezing and breaking down, watched in disbelief as the American columns relentlessly pushed through the snow. The miracle of the Bulge wasn't just the courage of the infantry, it was the stubborn refusal of the mechanics to let the cold win. They thawed out the engines, they fixed the tracks, and they delivered the armor that broke the German ring. When the war ended, the landscape of Europe was littered with the carcasses of armored vehicles. The German wrecks, the Tigers, the Panthers, the King Tigers, stayed where they died. They were too heavy to move, too broken to fix. They were monuments to a failed philosophy of uber-engineering. But the American wrecks were gone. They had been recovered, repaired, repainted, and sent back into the fight. The U.S. Army in Europe was a phoenix army. It rose from its own ashes, again and again. The statistics are humbling. During the European campaign, the U.S. Ordnance Corps repaired and returned to duty over 12,000 tanks. That is equivalent to the entire armored force of the German army on the Western Front, restored from the dead. The German leaders had underestimated the American mechanic. They looked down on the grease monkeys and the factory workers. They believed that war was won by the warrior spirit. They didn't understand that in the 20th century, the warrior needs a support team. They didn't understand that a welder with a torch is just as strategically important as a gunner with a cannon. The legacy of the American repair crews is the M for Sherman itself. It wasn't the best tank. It wasn't the toughest. But it was the tank that was always there. It was there because thousands of unnamed men worked through the night, in the mud and the snow, to turn a wreck back into a weapon. They proved that the wrench is mightier than the sword, provided you have enough spare parts. As the victorious columns of Sherman's paraded through a ruined Germany, many of them bore the scars of weld patches, battle wounds that had healed. They were ugly, battered, and triumphant. The ultimate symbol of an army that refused to stay broken.